So, we got some interesting notes today, so I want to get through this kind of quickly. But again, this is really important stuff, especially looking ahead to even units past this unit. This is really important information that we're going to need to commit to memory. All right, once you move on to Monterey Trail next year or whatever high school you go to, they're going to assume that you know how to find the slope of any line. Okay? So we really need to make sure this year we get it down pat so that we're not behind next year. So we've got a point right here and a point right here. Okay, we got our 2 points. That's all we really need. We're going to start with our left point. Start with the left point. And we're going to count how many units we have to rise up to get to where this point is at on the graph. So it looks like 1, 2, 3, 4, 5, 6, 7 spaces. Right? And then we have to run over 1, 2, 3, 4 spaces. Okay, and what we just formed here is a slope triangle. Remember that vocab word from yesterday. Slope is equal to rise over run, which is the change in y value divided by the change in x value. We rose up 7 units, so our change in y is 7. And then we ran over to the right 4 units, so our run is 4. Can we simplify 7 over 4? No, definitely not. So that's our answer. Okay, please make sure you're making corrections in red so that you know what you were able to do on your own and what we went over together in class. Well, number 2, again, we start on the left. We're going up 2 over 1. Y equals 2 over 1. Sorry, m equals 2 over 1. Which just equals 2. All right. Number 3, we're starting right here at the origin. Is number 3, does that show us a proportional relationship?
Yes.
Yeah, it sure does. It's going through the origin, and it's a straight line. Just want to point that out. To get from our left point to our right point, we're going to go up 1, 2, 3. And then we're going to go over 1. M equals 3 over 1. And that just simplifies to 3. So this is what your paper should look like. There should be these little bumps from space to space, just like with scientific notation. I said it then and I'll say it now. If you don't start out doing the bumps, you're probably going to feel more confident with doing it just by looking at it than you actually are. Eventually, you're going to skip a row or your eyes are going to trick you and you're going to miss something. And if that's on a test, there's nothing you can do about that, right? So we got to, at least when we're starting out, make sure we're doing these little bumps so we can see exactly where we're moving. Yes? Yes. Is that okay? Number 4, how many units do we have to rise in number 4? 3? 1, 2, 3. Looks right to me. And then how many units are we going to run? What's our run? 2. 1, 2. Rise over run is 3 over 2. Can't simplify that anymore. So that's our answer. Yeah. So you're saying like you went over here and then up?
Yeah.
That's fine as long as you're able to differentiate which one is your rise and which one is your run.
Okay.
Yeah, as long as you don't mix them up, that's fine too.
Okay.
And that was actually a really great question. So what Noah asked was, okay, I know I start with the leftmost point, but what if I did the run first and then the rise? Well, our run value would be 1, 2, and our rise would be 1, 2, 3. It would be the exact same slope either way. You just have to make sure you know which one is the rise and which one is the run. Okay, it's all about direction. And I completely forgot to ask on any of those 4 questions whether we were walking uphill or downhill, right? So that's how easy it is to forget about adding in your sign when you need it. Are any of these graphs sloping downhill from left to right? No. So luckily we're all good with 4 positive answers, but don't forget about looking at the angle or the direction of these graphs, okay? Because we get down to number 5, and hey, what's going on with number 5? It's sloping downhill, right? Thank you, Brazon. We're still going to start at the left. We're going to rise down to, and then we're going to go over 1, 2, 3, 4, 5. Two over 5 is what we get for our slope there. That's right. See, look at how easy it is to forget. I'm doing it all the time. Negative 2 over 5. We're sloping downhill from left to right. If I can forget it that easily, so can you. Don't be like me. Make sure you're paying attention. Number 6. Again, are we sloping uphill or downhill here? Downhill, right? So right away we know our slope's going to be negative, so I'm going to write that out so I don't forget like I just did. Did we? Oh, we might have. Our rise was 1, 2, 3, 4, and our run was 1, 2, 3, 4. Therefore our slope, what's 4 divided by 4? 1, right? So our answer is negative 1. I'll move it up. There you go. And just as a reminder, if you got that right, you have nothing to change, just put a little check mark so you know that you got it right. Number 7, we're going to start on the left and we're going to rise down 1, 2, 3, 4 spaces. And then we're going to run over 1, 2, 3, 4, 5 spaces. Rise over run is 4 over 5. And is our answer going to be positive here or negative? Negative. Definitely going to be negative, right? Number 8, we're rising down 1, 2, 3, and we're running over 1. Rise over run is 3 over 1. That just simplifies to 3, right? Negative. Oh, but it's got to be a negative 3 because we're sloping downhill. Yep. That's right. Great catch. Thank you. Questions on the front? Perfect. I'll give you a couple seconds to finish writing that before we flip it over, and then quickly run through the backside. All right, let's take a look at the back. So, which one did we go over together? Does anyone remember? The first one we did together? Okay. So, for the first one, I'm just going to quickly, if you didn't get the answer yesterday, here it is. We had +1 on the top, +3 on the bottom. 3 over 1. M is equal to 3 for the first one. Okay, now let's take a look at number 10. So again, we're going to count how many numbers we moved from space to space. So from 12 to 24, how much did we add? 12, right? And from 24 to 36, we also added 12. What about from 6 to 2? What do we add to 6 to get 2? Negative 4. Thank you for that. Or we could just say that we're subtracting 4 from 6. And subtracting 4 from 2 will give us negative 2, right? So our change in y is positive 12. Our change in x is negative 4. So change in y over change in x is 12 over negative 4. Now I saw a couple people leave that as their answer yesterday, which is technically correct. However, it's not simplified, right? How many times does 4 go into 12? 3 times, right? And what's a positive over a negative equal to? A negative. Always, always, always. Number 10, number 11. How do we get from negative 5 to negative 3? What's our change in x? From negative 5 to negative 3? Adding 2. Thank you, Leslie. We're adding 2. Just like with negative 3 and negative 1. What about from negative 12 to negative 4? What are we adding there? We're adding 8. That's right. Plus 8 on both of those. Change in y over change in x gives us m equals 4. So just as a reminder, with tables, we don't see the direction of the graph, so we can't tell by looking whether it's positive or negative. That's why we have to keep in mind that our signs on our changes do matter. Like up here with negative 4. That's where our negative sign came into play. All right? From 11 to 7, that's minus 4. From 5 to 10, that's plus 5. 5 over negative 4 is our m. Can't simplify that anymore. And actually, whenever we have a negative sign in our denominator, technically you don't have to do this. I would just prefer that you do this. Write out the negative sign either in front of the whole fraction or up on the numerator. You don't want to leave a negative sign in the denominator. That just looks kind of strange. So m equals negative 5 over 4. Number 13, what's our change in x? From 40 to 35, what did we do? What's that? Minus 5, exactly. Minus 5, minus 5. What about from 10 to 15 and from 15 to 20? Oh, that's plus 5. Great job. Our slope's going to be change in y over change in x. What's 5 divided by 5? It's just 1, right? And then we have a positive divided by a negative. We get negative 1. Change in x on number 14 now is plus 1. Plus 1. And our change in y is going to be minus 10. Minus 10. Negative 10 over positive 1 is negative 10. How are we feeling about the tables? Thumbs up, down, sideways? Just to get an idea. Okay. Good. All right. we got to get going on the notes, so I'm going to kind of just breeze through these last 4 just so you can check your work and get your answers. But it's pretty repetitive at this point, so we're just gonna keep going. So we add 2, we minus 7. Slope is negative 7 over 2. Minus 8 plus 2. 2 over negative 8 gives us negative 1 over 4. Negative 1 to positive 2 is plus 3 under plus 7. So our slope is just 7 over 3. And then here we've got plus 4 and minus, oh actually no, that's a plus 4 too, right? I think. That could be wrong. So if our slope is just 4 over 4, that's going to simplify to what, everybody?
1.
1, thank you. Great job. Questions on tables or graphs, either one. All right. Go ahead and give this worksheet to whoever's in seat number 1 of your group, please. And then get your notebooks out and all set up for this.